So welcome to this new tutorial. In this we are going to develop a ERC-20 Exchange App with UI. And so apps are basically decentralized applications that works in the Web3 space. So to get started with it, firstly we will open the VS Code, and then we have already created the repo which has all the code for this project, and we are going to clone that repository first so that we can step by step complete this project. So once the VS Code is open, we will just open the terminal and we'll copy and paste this command here. So this will basically clone the GitHub repository for this. So the project repository is copied, is cloned here, and as you can see inside the root directory there are two directories: CodaSwap Smart Contract and Web App. So basically this CodaSwap Smart Contract is the folder for the smart contract, and the Web App is for the front end and back end of the application. So without wasting any time, let's get inside this smart contract first. So we'll just go inside the root directory and then we will cd to the CodaSwap Smart Contract. And now what we need to do is that if we open this directory here, as you can see there is a package.json file. So if you open, you can see there are certain dependencies which are needed, which we need to resolve. So to resolve those, let's us install the dependencies first. So we'll run this npm install command and we'll wait for the dependencies to get resolved. So basically what is going to be done through this smart contract, let's have a look at the smart contract. So inside this smart contract root directory, we have this contracts directory. So inside that we have a token.sol file. So what basically a .sol means, it is written in Solidity language. So it has the extension of .sol, and it is highly commented, so you can always read through the code and you can get very good clear understanding of it. But I can explain this, that it basically does 4 functionalities, and all these 4 functionalities are defined inside this smart contract. And so the functionalities are like, we can send some ETH, some ethers, and we can get back tokens in exchange of it. And the exchange rate is also defined, then I will get to show you that as well. So just a minute, let's check which is the function first. So this is a function to exchange ethers for tokens, and we are calculating it as like we are conversing it into 10. So if you want, you can also multiply it to 100 as well. So that means the value that we are giving in ethers, it comes in WEI, and to that we are multiplying 10. So if 1 ether equals to 100 V, so that means 1 ether equals to 1000 Coda coins that we are creating, that is our customized token. So that is basically what we are going to do through this contract. Other than that, we are also going to transfer these Coda tokens among Ethereum addresses, and we would also be able to get back our ethers in exchange of these Coda coins. And there will be certain amount of platform charge that will be costed due to this whole conversion. So now as the dependencies are resolved and all the node modules are installed, so let's just quickly compile our smart contract. And to do that, we will run this command. So you are using Hardhat here to compile the smart contract, and as we hit enter, the compiler is downloaded and it has compiled the Solidity files. And if you notice, we have got this artifacts folder here, and inside the artifact folder, after the compilation is done, there is the contracts folder, and inside it there is a token.json file. So this is basically the compiled version of our smart contract. This is the ABI, which is the application binary interface. So it is basically going to serve as an interface for our Node.js application to interact with the smart contract once it is deployed. So we have compiled the smart contract and it's time for us to deploy it in the network. But before that, we need to start a local blockchain network, right? So for that, we are going to use Ganache here. So we are going to run this Ganache command to start the network, and we are starting it at 0.0.0 and in localhost 8545. So our network is already started and it is up and running. As you can see, we got 10 accounts with 1000 ethers loaded on each account, and we've also got the private keys of those networks as well. So now let's get started with the other steps. So now the next step will be to deploy our smart contract. So we are coming back to the terminal where we have run the commands related to the smart contract, and we are going to run this command as well. So npx hardhat run scripts/deploy.js. So as you can see, here is a scripts folder inside our CodaSwap smart contract folder, and in this scripts folder we are having a deploy.js file. So inside the deploy.js file, what we have is basically the code which is going to deploy the smart contract in our local blockchain. So let's get started with the deployment. So we'll hit enter. And as you can see, it is deployed in our smart contract, and we have got address for that smart contract as well. Let's keep it with us so that we can use it when we need it. And we are going to need it in the future steps as well. So with this, the smart contract is compiled and it is deployed in our local blockchain. We can also confirm it from here as well. As you can see, there is a transaction that has taken place and it gets a message as contract created. So after the contract is created and deployed successfully, let's move to our web app. So we just open the web app and we will make a new terminal tab. And in this new terminal tab, we will just cd over to our application and then inside our web app directory. So once we are inside the web app directory, as it is a Node.js folder, so again we need to resolve some dependencies. So to resolve these dependencies, we are going to run this particular command. And we are going to wait for the dependencies to get installed. So the node modules are installed. So now we can run this npm start command and it will start the web app. But before doing that, let's just open the public folder. Here we have the front-end files like the index.html, script.js and css. So we'll open the JavaScript file. So what we get is basically the code here is the main function of our web application in terms of our front-end view. So this is going to interact with the smart contract and through these JavaScript functions that we are going to have here. So these are the JavaScript functions. Again, this code is also very well commented for your better understanding. So here every function like transferring of tokens, sending tokens back to the contract, everything is created. And through these functions using the Web3 library, the JavaScript code will communicate with the smart contract. And basically the smart contract is going to perform all the work for you. So JavaScript is working as a mediator. And it will contact with the smart contract through the API or application byte interface. So let's see where our API is here. So we have defined a constant known as contract API and we also have a contract address. So let's just paste the contract address that we have just now found. And that's wrong. So we'll just have the contract address here, and to get the API, we need to go to the Coda Swap smart contract folder. Inside this, in the artifacts folder, we are going to the contracts folder. And inside the contracts folder, we are going to go to the token.json folder. Inside, as you can see, here is also an API column. So let's just minimize it because it is a long piece of code, as you can see. So we will just copy it from here. And by doing this, the whole code is going to be copied. So let's just do it and we'll paste it. And it's ready. So we have updated the contracts API code as well as the contract address in our JavaScript file. So it is totally ready now. So now we are going to start our web app in the local host. So we'll use the npm start command to start our web app. And we will hit enter. So as you can see, the server is running on port 3000. So let's just go to localhost 3000 and we will hit go here. And this has opened the app, and as I already have my MetaMask installed in the browser, so it is coming very smoothly. But for you, if you have not installed the MetaMask browser, you can just install the extension on your browser and then we can start with it. So now we will just go to this pop-up and we have selected this account 3 that is topped up with 900 ethers and we will connect with it. So in my case, the network is already connected, but in your case, you might need to add the network to the MetaMask in this manner and you need to approve it here and you need to switch to this network. So this is how you are connecting your local blockchain network to the MetaMask, because MetaMask does not have the local networks by default. So now as we have connected our network to the MetaMask, so let's try doing some things with it. So now we will add some Ethereum to let's just refresh our page for once. So as you can see, once we have connected with the MetaMask, there is the balance, it's coming in 0 Coda, because right now all the nodes that we have in our local blockchain network, they are not topped up with any Coda tokens. So let's just add some Coda tokens to our network node. So we'll just spend some Ethereum. Let's spend 100 Ethereums for now. And as we hit on send Ethereum for tokens, it will take some time. It will open a transaction. Since we are doing a transaction, MetaMask is going to help us in confirming or rejecting the transaction. And as you can see, there is some fees is there for this transaction that is being charged at this point. So it is deducting a total of 100.000, some number that is given, and this is known as the gas fee. So you can think of it as a transaction fee. So now if I confirm this, the transaction will get executed. As you can see, the balance is updated. So this is my balance in Coda. So now what is the next step that we can do? We can send these tokens to some other account. So for that, we will move to VS Code very quickly, and we will open our terminal for the server for our blockchain network, and then we will go there and we will take the address of any random account. So I'm taking the address of the second account, and once I've taken the public address, let's put it here, Control V, and now let's transfer some Codas. So let's transfer this amount, hit 2, and we return transfer tokens. So let's see, again the MetaMask pop-up comes up. If we reject, it will be rejected. So let's first reject it once, and once I've rejected, as you can see, the balance remains same. But and you can also check the transaction history from MetaMask as well. If you click on this, you will get that. See, it is confirmed, so it is here. So now let's transfer it again, and now we will get another pop-up, and if we confirm it this time, so it is done. And as you can see, the balance has reduced in my case because I have sent this much amount, so it will obviously it's going to decrease. So now let's check what is the current balance in terms of Coda in this particular Ethereum address. So if we come here and we hit the Ethereum address, and then we check the balance, and you can see the amount that I have sent precisely, it is here as well. So now we will try to get the Ethereum back from our Coda. So as you can see, we have this much of Coda tokens remaining. So we'll just copy it, and we're pasting it, just removing 1 0 to get a good idea. And we're trying to get Ethereum back. So now let's see what happens. So here, this is an estimated gas charge, and this is the total cost of the transaction. So now let's just confirm it. And once it is confirmed, as you can see, the balance is reduced here. And if we go back to the Ethereum balance of our account, as you can see, it is in some 900.799. So we have got some tokens back in the form of ethers. So this was about our exchanging our ERC-20 Exchange App with UI, and we have created it using Solidity, and we have used Solidity to write the smart contract. We have used Hardhat to compile the smart contract and to also deploy it to our Ganache local blockchain. After that, we have used Node.js to serve as a server for our web app, and we have used HTML, CSS, and JavaScript for the front end.